And as you can see, it printed out every single product on that page. It printed out the brand, it printed out, in this case, Lacoste. What's up everyone, and welcome to this video. Today what we're going to do is build a web scraper in Python. This video assumes that you're new to web scraping and you're fairly new to Python, so you don't actually need much to get started. It's tailored for beginners, and not only will you learn how to build your own web scraper in Python, you'll also better understand how web pages are structured, how data is sent over the internet, and more importantly, how you can extract that data in the format that you want. My goal on this channel is to help you learn programming by building fun projects just like this. So if you haven't already, make sure you click subscribe if you want to see more videos like this in the future. Alright, let's get started. So in this section, what I want to do is just spend a bit of time going over the behind the scenes of a web page. Web pages are structured in a certain way, and I think it's really handy, especially as you start off in your web scraping journey, to be able to understand exactly how they're structured so that you can get the data that you're after. You learn that becoming a good web scraper over time is just as much your ability to be able to understand a web page, how it's structured, how the data is delivered, and all of these different bits and pieces are just as much as the code itself. So we're going to be building a web scraper for this website called House of Fraser. It's a website that I shop online, and it has clothes and other bits and pieces. We're going to be building a web scraper for this in Python later on in the video, but very quickly what I want to do is walk through how we can inspect this website before we even write any code. So traditionally what most people used to do, and some still do, is they'd visit a website that they want to scrape, they'd right click and they would click view page source. This option is available in all browsers, and that would show you essentially all the code on the website. And back in the day, you could even copy the entire contents of this page, save this on your desktop and open it, and you'd be able to see the same exact website. But since then, websites and web frameworks have come a long way, so it's no longer easy for you to be able to find the data that you're after in this page source. It's a lot more complex than that. Sometimes data is hidden, and as web scrapers, you kind of have to adapt with not only newer frameworks that come about, but the tools and how websites are kind of built these days. And most people nowadays don't go to view page source, they use a tool that is way better, and that's called the developer tools. This is available on all browsers, and how you open it up is if you click view, you can click developer here. In this case, this is on Brave, and you can click developer tools here. But there is the shortcut that I use, which is Command Option I on the Mac. But of course, it depends on the browser that you're using. But once you've got it open, you can see there's a ton of information here. So let's quickly go through each tab. So the first tab we're going to look at is elements. And this is essentially page source, which is what we saw earlier. The difference here, however, is you can actually click onto each individual component. And as you can see, as you hover over some of these elements above, it starts to highlight parts of the web page. You can expand these. And what this is telling you essentially is that this element corresponds to the one that you can see here highlighted. So as a web scraper, it's very handy because it allows you to start targeting different elements on a web page, or kind of verifying that the element that you're after is the one that you've selected here. Now, the most useful option in this tab is by far this one on the top left here. As you can see, if I click onto this allows me to move my mouse over the web page and target and pick specific elements. And when I pick one of these elements and I click it, what will happen is it shows me the exact code that corresponds to that element. And this is super handy when it comes to web scraping. The reason why this is key is because what this allows me to do is quickly pinpoint exactly where the data that I'm after is, and see exactly what part of the code that corresponds to. Now, there's a few more tabs that I want to show you. I won't go into too much depth, but I think these will be really useful in your web scraping journey. The next tab that I want you to take a look at is the console tab. Think of this as a logging area where developers of this website will use this as a place to be able to log info or errors that might occur on that web page. For production websites, developers shouldn't actually be logging here, but you might find sometimes, depending on the website, some developers just forget to delete those lines of code, and you might end up seeing some funky messages here. But otherwise, this is the area where you can see those log statements, but typically it will show you different errors that have occurred on the web page. Now, you will find that most websites actually have this, in that there are often a lot of errors, but for the most part, it doesn't prevent the web page from loading, in this case anyway. The next tab that I want to skip to is the network tab. This is probably one of the most powerful tools that web developers, not only front-end engineers, but back-end engineers have in their toolset. This is essentially showing you the moment that you hit enter or you visit this website, every individual request that is being made between you and the web servers going back and forth. The reason why this is so powerful is you can filter down to every single request that this website is making, both when you visit it, but also while you're browsing through it. And although you might think not much is happening, you'll find a lot of different scripts are running even when you're on the web page that are completely unrelated to what you're doing. Now by default it will be empty, but all you need to do is hit refresh. And once you refresh the page, you can see all the requests that are happening. You also get to see this really handy timeline that shows you all the requests that are being made. And then if I click onto one section, it will filter down the request that was made in that time period. As you can see, this is the first request that we made, which is visiting houseoffraser.co.uk. And if I click onto it, I can then filter down and see much more information. I can see the request URL, I can see the status code, the response that we got back, which was successful. I can see the response headers. So for example, this website is using gzip compression. I can see what cookies they're setting for this website. We'll talk a bit more about cookies later on. And I can see a bunch of useful information that not only is useful if I'm a developer on this website and I'm debugging, but also if I want to inspect and potentially web scrape this website, or if I want to do something else. Okay, I'm going to show you one more tab and then we're going to start building our web scraper. And that is the application tab. This application tab shows you a few different things, but I want you to focus on the storage area. Let me explain what storage is in the context of websites. Very often websites will need a place where they can store some data. Data that might be specific to you, as well as data that will help them track your behavior on the web page. For example, if a website is running a lot of Google and Facebook ads, storage is the area where they're going to be able to store customer information. Essentially identifies that will allow them to track your behavior as a customer or a potential customer on their website. And they'll either store data in local storage, but most often it will either be in the session or in cookies. So if I click onto cookies and then click onto House of Fraser here, you can see all the different cookies that have been set. They will often be key pair values, so you'll see the name, you'll see the value, and in this case you can see a lot of values are quite difficult to decipher, like it's not clear what they are. You'll also see when this cookie is set to expire, and that might be useful, but for the most part these cookies are being used and they will be used throughout your time that you spend on the web page for them to be able to do all sorts of things like track and target ads towards you. But it's not just ads, it's also other things that allow them to be able to save your settings for that website. For example, you might want to filter out particular products and you save that filter. They allow you to do that and they will most likely be storing that configuration in the cookies here. Okay, so that's a quick 101 of the developer tools. If you stuck around, honestly, this is probably one of the places that you will spend a lot of time, especially when it comes to web scraping. It's also a very powerful tool that if you can grasp and get good with, it will build up your understanding of web development both on the front end and on the back end. So I highly recommend looking more into it. Do let me know in the comments below if you want me to make more videos about this. Okay, so let's move on and start building our web scraper. So the first thing I've done is I've opened my editor in a folder and I've called it HOF Scraper, House of Fraser Scraper, and I've created a file called domain.py inside this folder. I've opened up the terminal because I want to run a few commands, one of which is creating a requirements.txt file. So let me do that by typing in touch requirements.txt. And the reason why I'm creating this file is because I want that to be the file where we specify all the dependencies that we need for this project. It's worth getting into the habit, especially when you're working with Python projects, to have one file that stores all the dependencies that you need, along with the versions of those dependencies. Because if you don't, you're going to install a dozen dependencies and then later on forget which ones you installed and what versions of those that you did install. Now, if you've watched my previous videos, you know I also like to create a virtual environment. A virtual environment is an isolated place where we can install all of our dependencies. And because it's isolated, it won't interfere with other Python dependencies that we have installed on the system level, as well as not interfere with other dependencies in other virtual environments. Let's create the virtual environment. I'm going to do that by typing in Python 3 -m. Then a -m, by the way, is specifying that we want to use this version of Python to run the following, what comes after. In this case, venv, which is the command, shorthand for virtual environment, and then we have to give our virtual environment a name. I'm going to call it venv. If I tap enter, you'll see that a folder is created on the left hand side called venv. That is our virtual environment. That is where all the dependencies will be installed. Okay, one more thing that we need to do is activate this virtual environment. We can do that by typing in source venv. I'm going to use the autocomplete here, bin activate, which is a script that activates that virtual environment. Once you tap enter, you'll see on the left hand side that this virtual environment has been activated, and it shows you the name of the virtual environment. Okay, so that's good. Now it's time to install the dependencies that we need. The first one that we're going to use for this project is called HTTPX. Now, instead of going online and trying to find out the version that I want, which is the latest version, I can do that with a neat trick here. All I need to do is type pip install HTTPX and then followed by 2 equals. If I tap that, it's essentially resulting in an error where Python's saying couldn't find the version that you were after, and it's because I never gave it a version. But the handy thing is it shows you all the different versions that are available, and the one that I'm going to install is this one, because I believe 1.0.0 B0 is a beta version, so I want install that. So if I want to install this, what I will do is go into the requirements.txt file, type HTTPX, and make this a bit bigger, and then equals equals are followed by the version. Okay, well, it didn't copy the one that I was after, so if I copy that and then come back here and then save that there, and then so now that's been specified, we can now install this package. Okay, there's one more package that we need, and it's called Beautifulsoup. Beautifulsoup is the package that's going to allow us to search for different elements on the HTML page that we scrape. So again, I'm going to find out the version by typing in pip install Beautifulsoup 4 with 2 equals. That will tell me all the different versions available. I'm going to install the latest, which is 4.12.3, and I will type that here. So Beautifulsoup 4 equals 4.12.3. And then now if I want to install the requirements or the dependencies defined in this requirements file, all I need to do is type in pip install -r requirements.txt, tap enter, and that will install all of the dependencies in my virtual environment. Right, so the first thing I want to do is import the HTTPX library, and I can do that by typing import HTTPX. Now, this is a library that you can use to make HTTP requests to different websites. There is another library called requests that I use quite often, but HTTPX has one unique feature that allows you to make asynchronous requests. HTTPX is a library that allows you to make HTTP requests to websites, and as a result, we're going to use it for our web scraper. The more popular library is requests, and I've used that before, and I still use that quite frequently. But the advantage that HTTPX has is it has some features that allows you to make asynchronous requests. We're not going to be doing that in this video, so technically we don't need it, but we are going to be using it for this example. Once you've imported the library, the next thing we want to do is make a request out to the House of Fraser website. So let me quickly show you, because there's a specific page that I want us to target. Okay, so I'm back on my web browser and I'm on the House of Fraser website. I'm going to go to the men's section, and then I'm going to click on hoodies and sweatshirts. This is the page that I want to target, and the reason why is because this page has a list of products. You have filters on the left hand side, but the thing I like about this is, as you can see, there is some kind of structure. You don't need to look at the code to know that every product has an image. There's the name of that product, in this case, double knit polo ralph hoodie, and the cost. Now on the left hand side you have the different filters, but without even looking at the code, you can kind of tell that this has some kind of structure. Just based on intuition, looking at this page, you can see that for every one of these hoodies there is an image. There are these 2 icons, that one presumably which probably saves it. In this case it adds it to the wish list actually. The name of the hoodie, the brand, and the price. And if I scroll down, they all follow that same structure. Each one of these is almost like a card, right? And each one of these cards has these different elements, and we're going to explore that a bit more. But the point is that this is the page that has all the hoodies and sweatshirts, and I want to take the URL here. So copy this and let's paste that back in our editor. So I'm back in my editor here, and what I've done is I've created a variable called URL, and I'm going to paste in that website URL. And then what we're going to do is just add some boilerplate Python. So if name, I just like to do this because it's nice to tell Python when you run the script exactly where it should start. So in this case, we're going to create a function called main, or method called main, and we'll leave that empty for now. Right, so the first thing that we want to do is we want to use HTTPX to make a request out to this URL. And there's one thing that I want to show you. We're going to talk about headers in a second, but to do that, it's quite simple. So all we need to do is type in response. I'm going to store the response in this variable, and then HTTPX.get followed by the URL. Now, if I run this, I'm going to show you let's do a print response, even though it's not going to get that far. But if I run this, I'm going to show you exactly what happens. So you would think that this will work and we will get back a response, but it's not going to work. So if I type in Python main.py, you can see that it's taking quite a few seconds to load, and it eventually times out. And as you can see, it says the read operation timed out. Now, in your web scraping journey, you're going to see this quite often, in that you might get a URL, you make a GET request, and you print out a response, and you don't get back what you expect. When you go to a web browser, on your favorite browser, in this case I've used Brave, you paste that URL and you hit enter, it shows you the web page. So the question is, why is it we're getting a different result here? Because essentially we're doing the same thing, but the answer is not quite. So let's go back to the web browser, and I'm going to explain exactly what's different to this request that we're making here and the one that we're making when we visit the page on our web browser. Okay, so I'm back on my web browser, and what I've done is opened up the developer tools, and I've got the network tab open. And what I'm going to do is, as you can see the URLs here, I'm just going to tap enter, and the network tab is going to show all the requests that have been made between my browser, the client, and the server, which is the website. And the request that I'm after is the first one that we make, which is, just when we visit the web page. And that one is, if I click here, you can see it's this one. So if I click onto this one, let's inspect the data here. There's quite a bit going on, but I want to go over this section. So the first thing you notice is this general section, which shows the URL. It shows the status code that we got back, which was the 200 OK, and it shows the IP address of the server that gave us back that response. That's all well and good, but what we're after, or what we want to look at, is actually further down below, and it's what's called the request headers. Headers are very simply pieces of information that our browser will send when we make a request out to houseoffraser.co.uk/men/hoodies and sweatshirts. On our browser, when we visit any website, not just House of Fraser, our browser will send more bits of information along as part of that request. There's different bits of information, but one category is called headers. Now, what's in these headers will vary from website to website, but there are some things that actually stay the same, and they will be the same for any website that you visit. Some of these headers are quite easy to understand. You can quickly Google them, and you can ask ChatGPT. But other headers might be a bit more obscure, and they might not be the most easiest to decipher. For example, these accept headers indicate the kind of response we're happy to accept back from the server. But there are often common headers that will always be sent to every website that we visit, and one of these headers is known as the user agent. This is the one header that I found that you almost always need to include when you're making a request with HTTPX or any other requests library that you're using in Python. So what I'm going to do is I'm going to copy this here, but in future what you can do is just go onto Google and type my user agent, and you will get that here, and you can copy it from there. But the point is, I'm going to copy this because we're going to go back to the editor, and we're going to paste that there in the headers variable. I'm going to copy this and go back to the editor and explain why we need this. But in future, if you need to know your user agent, you don't need to do this. You can just open up a tab and type my user agent, and you will see the result here, and you can just copy it from there. Okay, so I'm back in my code editor, and what I'm going to do is I'm going to create a headers variable, and that's going to store a dictionary for my headers. And then I'm going to type in user agent. That was the header that we copied, and then I'm going to paste what I had in the clipboard. I showed you that in a web browser, when you make a request out to a website, the web browser will automatically populate these request headers. This request is then sent to the server, and then the server typically responds back with a HTML page. Now that's all well and good there, but if you're making a request in code using, in this case, the HTTPX library, and you don't include headers, it's most likely that your request will fail. That's what I found in my own web scraping journey, where if I don't at least include this user agent header, the request fails. Now in some instances, I have found that the user agent header isn't enough and that you need to include more headers. And that's the reason why I kind of showed you how you can get hold of those headers in the web browser. And all you need to do is copy over those headers, put them here, and then one by one you can remove them to see which one or more of those headers were the ones that you need to include as part of the request. That's what I typically do when I build web scrapers, and I have found that headers often catch out beginners. Now that we've got that, let's include this in the request that we fire. So in this get method, what we do is we type headers and we set that equal to headers, and that will then send the headers as part of that request. I can then run this script again, python main.py, and as you can see, we get back a 200 response. 200 means that everything was okay. Now if we want the HTML in the response, we can go here, and then what we do is we type response.text, and that basically prints out the HTML. So hopefully if I run this again, as we can see, we get back the HTML, which is going to be quite a long scroll, but we won't scroll through all of it. So now that we've got the HTML back, how can we inspect it to find the data that we want? And this is where Beautifulsoup comes in. Beautifulsoup is a really handy library that once you give it HTML, it does some magic behind the scenes to give you back a soup object. This soup object is just a representation of your web page, but the cool thing is that you can search in that object for the elements that you're after. It just provides a really easy way for you to be able to query elements that are on that web page. So to set up, what I'm going to do is import. So I'll type in from BS4 import Beautifulsoup. And then if I come down here, so I'm just going to say that this is the response HTML, set that equal to response.text. Oh, I didn't mean to open that. I meant to copy that. And then if I want to create a soup object, I will type in soup is equal to Beautifulsoup, and then I'll pass in the response HTML, and then I just need to tell it that I want to use the HTML parser. And then what I can do from there, if I just print out soup just to show you exactly what it's done. So if I go into the terminal, and then if I run this, now on first glance you're probably thinking, well, this just printed the same thing as before, and it did. It gives you back the HTML, but this is a different object, and so I'm going to show you a better example. So for example, if I want to find out, all the links on that web page, I can type soup.find, and this is where it's handy. It gives you all of these methods. So I can do soup.findall, and then I want to find all the A tags, which are link tags on that web page, right? So this is where the power of soup comes in, because now you have access to all of these methods that allow you to query that HTML page. So if I run this, as you can see, it's printed out all the links in this list. Now if I run this, as you can see, it's going to print out all the links that it found. It's not the most easiest to see in this terminal, so I will just print out the len, which is the length, so how many elements it found. If I run that, it found 764 links, so that sounds about right. And then another example is if I want to find out all the elements with a particular class name, I can do that by typing in, I'll just do print soup.find all, and then what I'll do is I'll pass in class underscore, set that equal to the name of the class that I want to search for. I can't remember off the top of my head what classes were in that web page, so this might not return anything, to be honest, but that's fine. I just want to show you exactly how it would look if you want to find all the elements with a particular class name. And so if I run this, I doubt this will work. Of course it's empty because there's probably no elements on that web page that have that class name, but this is an example, and this would work if you had a valid class name for the HTML that you're passing in. Okay, so I'm back in the web browser, and the reason why is because now that we've got the soup object set up, the question is, how can we find out the exact elements that we want to target on the page? How can we pinpoint them? And how can we search for them so we can get the data that we're after? And to do this, I found with web scraping projects that a lot of it is just taking a more free-flowing approach, where you're going onto the web browser, you're inspecting the elements, you're trying to find out the commonalities and the differences so you can target the elements that you're after, and then translating them and putting them into code. So this section is actually going to be a lot more free-flowing, and this is going to be useful for you not only in this project as we work through this example, but in your future web scraping projects too. So now I'm on the web page. What we're going to do is open up the developer tools, and then if we go to the elements section, and I mentioned how this icon or this option here is actually very handy, and what I want to do is pinpoint each hoodie on this page, right? Each one of these is a project, and ultimately what I want to do is get the image, we'll get the title, and then we'll also get the price, right? And that's where this option is very handy. So if I click onto this, this allows me to select an element. So what I'm going to do is, as you can see, it's starting to select each individual element. Now, I don't want to kind of go into this detail yet where I go right down to the specific element. I kind of want the overall, we call it container. So let's see if I can get the container. There we go. You see? So that gives us the container. So this tells me this contains the hoodie or object or the product. And I guess if I can find the same one here, in that case, yep. So let's select this container and see if we can find out some kind of identifier or how, and then how we can get the data inside. So as you can see, this container is now selected, and this is the element, right? And I can see it's a div tag, and it has this class s-product thumbbox, right? And so that gives me a good sign, because I'm guessing if I select the next hoodie, we will see that it also has it's also in a div, and it also has the same class name. So that's very handy, because I now know that if I want to get all of the hoodies on this web page, I need to search for all div elements that have this class name. And so that's good to know. So when we go back to our code editor, that's what we're going to do. So let's actually go into this container here and see how the information is structured. So it seems like there's just one row, and if I go into there, I have the product image, so that's good. If I go into the product image, I can see, let's see if I can find an image somewhere. So this is the link, and there's another div, and there we have it, right? So here's our image element. Here's the class. The class is RTIMG, main image, and image responsive. So I guess, again, this is example of like this being free flowing. I guess this class here, it has main image. So I wonder if the other hoodie or the other ones have main image. So if I select the image this time, yep. So it seems like all of these have main image. So that's good to know, because what I can do is I can say, well, in this product thumbbox, in this div, find the image that has this class. But in saying that, given that there only seems to be one image, it can be even simpler. We can just say that we want to find, or we want the image contained in this overall div container, right? So that's another approach. So when it comes to web scraping, you might find that there's different ways to get down to the element that you're after, or the value that you're after, right? And there's different approaches, and all of them are fine, right? It's just about picking which one, or finding the one that works, and then going with that. So now that we've got the image, the question is, how can we get the price? So let's see if I go here, or I can see here, I can probably select the price, and that is a span class with this, right? Okay, so we've got quite a few things here. This has given me a decent intuition. I think it's time to go back to the code editor, and I'm going to show you another approach for being able to use Soup in an interactive way to find out the elements and the data that you're after. Okay, so I'm back in my code editor, and I'm going to show you how you can start extracting some data out from this Soup object. And we have an idea now of the different classes and the different elements that we're after and what attributes they had. But I'm also going to show you how I typically, especially when it comes to web scraping projects, interactively find these elements in the debugger. I just find it easier and quicker for myself, and I'm going to share that with you, because if you find it helpful too, you can adopt that as a practice when you're building out your web scraping projects. So the first thing is we want to extract out all of the products. There were hoodies and sweatshirts, all of the products on that web page. And if you remember, each one of those had a class name. So they were contained in a div container, and each one had a class name. If I remember correctly, it was s-product thumbbox, right? So what we're going to do is find all the products on the page that had that class, right? So we can do that by typing in, I'll set it equal to products, and we'll type soup.find_all div, followed by this class directive. And so we're going to find all the div elements on this HTML page that contain the following class name, right? Keyword here is contains, right? So as long as it contains the text that we're going to put in here in the class name, it's going to match them, right? So that's quite handy. But it was product thumb box, right? And so if I type print products, in theory, that should print out all of the products, right? So let me just get rid of that one below there and give this a run. And as you can see, it seems like it's printed out every product. And I'll just verify by printing out the number of products by using len. 59 products found, right? And that's presumably because it's targeting the first page that was loaded. Now, I want to give you a taste of this debugging flow that I'm talking about. So what I'm going to do is I'm going to set a breakpoint just before this print statement, and I can do that by typing import pdb and then pdb_setTrace. And then, just to make this easy for myself, I'm going to create a variable called first product, and that's going to be set equal to the first product from this list here. And so if I now run this, you can now see that the debugger has stopped at the point where I've set the breakpoint. The reason why I like this is because I've got a shell into my script, and that allows me to run commands here without having to write the code and then running the script again. Instead, I can just run or write the commands directly in the shell. Okay, so let's inspect first product. I created that variable so we could have a look at the first product in that list. So if I type first product and I tap enter, as you can see, this is the HTML element for that first product, or that first S product thumb box, if you remember. And as you can see, as I scroll up, I can see different bits of information. So straight away I see the price, I can see the name of the product, and I can see the brand. And so I can see straight away without having to go to the browser, I'm in the debugger now. These are all the bits of information that I want to extract, right? And now what I can do is interactively target these using Soup. I can start to query for these, and then once I've got the selector, then I can put that into code, and then we're good to go. So let me show you an example of that, right? So if I go down here, let's say that I want to get the product description brand, right? And I know this is a span class, right? So it's a span element. It has the class product description brand, and I want the text inside here, right? So that's good enough for me. So what I can do is type first_product, and then I want to find the span tags within with a class name that contains product description brand. And there you see it's returned, right? And then I just want the text inside, and there we go, right? And now I've got the selector that I need to get the product description brand, and that's fantastic. Let's see if I can do the same thing for the price. So the price here is another span tag. It's got this class. To be fair, I can probably just copy that, but let's just for the sake of accuracy copy the entire thing. So again, I can do the same thing, but this time for the class here I can put that, and as you can see, it's returned this. Seems like it's got a space there. I guess I can strip that, text.strip, and then that just gets rid of the space. But the key thing is I found the selector that we need to get the price, I found the one that we need to get the brand, and of course I can do the same thing if I want to get the name, right? So this is quite handy for me, especially when it comes to web scraping. I can do this in the shell, I can quickly find the selectors that I want, and then I can go back into the code, put them there, and then that allows me to build up my web scraper. Right, so I've put these selectors in some comments here so that I don't forget them. And one thing that I want to mention here is I've worked on more than 50 scraping projects at this point, right? And some web scrapers that I've built, I've got them to run on servers overnight with a dozen different proxies, right? And I've experienced this scenario, and I think it's quite common, especially for beginners when they start out with web scraping, and even more sophisticated web scraper builders, if that's what you want to call them, is that when you run these web scrapers, sometimes they will just fail, right? And you will find one common error that takes place is, as you're scraping thousands and thousands of products, one of those products, for whatever reason, didn't have, you know, product description brand as an example, right? It didn't have product description brand. This line of code failed, and because of that, the entire script stops running, and it's a pain because a web scraper might be running overnight in, you know, especially it might be running on the server, and that's been the case for me. And you won't know about it, right, until you wake up in the morning and you see, okay, damn, well, I was scraping 50,000 items and it stopped at, you know, 24,000 because one of them failed, right? And you want to avoid that scenario as best as you can, right? So the best way to do that at the beginning is to add some very basic error handling, right? So you catch all errors, you just log them out, you take the hit. One of those products, for example, didn't work, and so you take the hit by just logging out the error. And then what you do is later on you start to adapt your web scraper to start dealing with the different errors that it will experience, right? You will find that these web scrapers are quite fiddly, and they will constantly fail for so many different reasons, and so you will constantly have to adapt and update your code to be able to handle these errors that come about, right? So when it comes to web scraping, you have to be very adaptable, and you have to, over time, ensure that your error handling is updated. So I'm going to start off by looping through every product that we found. So I'm going to type in for product in products, and then I'm going to run a method called extract product data. I haven't made this yet. I'll pass in the product, and then what we'll do is define this above. This is going to take a product, and then this is where I'm going to add a try except block. So very basic Python try, I'll leave it empty for now, except exception e, and then print e, right? And as e. And so what this will do is, we haven't populated the try block yet, but in here we're going to add our code that's going to extract out the brand, the name of the product, the price, and if for whatever reason it fails, we want to print out that exception, right? And the good thing with this, right, is as we're going through, there's only 59 products on this URL, if I remember correctly. But if this was going through, you know, the thousands of products, then if one of them failed, we couldn't extract it for whatever reason, this script will not stop running, right? It will continue and it'll go through every other product. So let's start off by getting the name, the brand name, and the price too. So I'm going to go down, given that we have these selectors here, bring those up, and we know that well, I'll put those here for my reference. So the first thing that we're going to do is get the name out, and I remember it would be product find. I can just copy this here, and it was name, and then we had I believe it was brand, brand, I can't type today, product description brand, cool, and then the last one is the price, right? So if I go here, and then what we'll do is we'll create a variable called price, set equal to that, then we can get rid of all the comments, and then of course we add product.find. That all looks good, and then the last thing that I'm going to do is just print this out, right? So we'll do an f string, we'll do name, we'll do brand actually first, followed by name, followed by price, and then we'll put in brand, name, price, and then I think that's good, right? So what this is going to do is it's going to get the name, the brand, the price, and it's going to print all of that out onto the screen. And if I go down below here, we're doing that for every product. I can get rid of these lines, we no longer need them. And then of course we've got some error handling in place, so that if an error occurs as it's trying to extract out some of this data, it will just continue. And that's exactly what we want, right? So everything looks like it's ready to run. So let's test this. I type python main.py, and as you can see, it printed out every single product on that page. It printed out the brand, it printed out, in this case, Lacoste, it printed out the name, and it printed out the price. And that's exactly what we wanted. We can see that the scraper is working, and that's good. So just before I finish the video, I want to show you a cheat sheet that I found to be pretty good for you to be able to really explore Beautifulsoup and how you can use it to find elements on a web page. This cheat sheet is particularly useful because it goes over looking for comments and exploring the tree, using CSS selectors, searching with them, searching by IDs, you know, all those different bits and pieces. All of this stuff is going to be very handy when it comes to you building out your web scraping projects. So I'm going to include a link for this in the description below, but I also highly recommend that you yourself explore Beautifulsoup cheat sheets. The documentation might be an overkill, so do check out cheat sheets, but ultimately when it comes to web scraping, every website is structured differently. Some websites might be structured the same, but you'll find a lot of websites are very different, and because of that, your web scrapers have to be adaptable, and you also have to build up your understanding of Beautifulsoup along with the selectors that they give you, because over time, the better that you get at Beautifulsoup, the easier it is that you'll be able to scrape those different websites. And one other bonus tip that I'm going to give you, and if you haven't already, make sure you subscribe, because hopefully this video was helpful for you, and hopefully these tips are going to help you in your programming journey and of course in your web scraping projects. Right, so I hope you found that video helpful. It was quite in depth. We did explore the developer tools. We did really pen into the specifics and the behind the scenes. I guess it's different from other web scraping videos that you might have seen on YouTube. I actually really enjoy building web scrapers. My forte is in backend engineering and cloud, and I do find that web scrapers kind of push me to inspect, analyze, and reverse engineer somewhat how websites work. And as I mentioned, every website's different, right? And so it kind of brings in some of those skills, and yeah, I find it quite enjoyable. So with that said, if you do want me to make more videos about web scraping, maybe you want me to go over the developer tools in depth even more, analyzing network requests, or even just building out web scrapers for specific websites, let me know in the comments below. Other than that, thanks a lot for watching. Make sure you like and subscribe, and I'll see you in the next one. Peace.